Namaste everyone. Welcome you all to Sadvidya Academy YouTube classes. So today's topic is Class 10 Physics Chapter 12 Electricity Part 2. In this particular Part 2, we are going to discuss about potential and potential difference. So what is mean by electric potential and potential difference? So in the previous part 1, we have discussed about the flow of current or the flow of charges in any electrical circuit. So the flow of charges is called as the electric current. But in the previous part 1, we have not discussed what makes these charges to move. Let us assume a conductor. Say for example, it is a metal like this. So let us assume this is a metal. Now, whether can you say that the electrons or the charges inside, there are plenty of charges inside the conductor, right? So whether these charges move by themselves of their own? No. So there should be some force which makes these charges to move from one side of that conductor to the other side. So what is that one which makes the charges to move from one point of the conductor to the other point? So that is why in order to explain this, we shall take the analogy of flow of water in a pipe. So it will be easily understandable. That's why I'll take the example of the flow of water in a pipe. When does water in a pipe starts flowing? So let us assume this is a tank. This is a tank to which I have connected a pipe here. Like this, I have connected a pipe. And when you can say that there is flow of water in this pipe, what is the condition? Only when the level of water in this particular tank is sufficiently large compared to the end of the pipe. Say let us assume that these are the two end points of the pipe. These are the two end points. Point A and point B are the two end points of a pipe. So we can say that there is flow of water in a pipe only when the difference in the level of water at point A and at point B, they are not the same. Say for example, if the level of water at place A and B are same, then water does not flow. That means in order for making the water to flow through this pipe, there should be a difference in the height of water between the end A to the end B of the pipe. Then only the water flows in a pipe. Similarly, in the case of a wire, if we assume that this is one end of the wire and this is one more end of the wire, end A and end B of the wire, then we can say that there is a flow of current in this particular wire only when the difference in the number of charges between the end A and end B is there is a difference in the number of charges. So how this particular difference can be brought about is the question. So here, how this in the case of a water, in the case of a tank containing water, how that difference in the height can be brought about? By using a pump. right, by using a motor. So what is the action of a motor? It generates the difference in the level of water, so that what happens? The water can flow this particular pipe. That means pump will keep the difference in the level of water. Similarly, in order for the difference to be there in the point A and point B of a wire, in the case of a tank, here is the level of water we are talking about, but here it is not water which is moving. Here it is nothing but the charges. The amount of charges present here at point A and amount of charges present at the point B should be different. Then only the current starts flowing in the wire. So that particular difference is called as the electrical potential difference. Say for example, if I consider this particular tank which is filled, so level of water here, we call this as the potential of potential at point A. What is the level of water here? Somewhere here. So if I connect this also to some other tank having only some level of water, so what is the potential at B? Potential at B is only this much. So if, say for example, the difference in the potential, the height of water in tank A and tank B is more. Say for example, here in this particular tank it has this much of water, so the flow of water will be large. So what happens when the difference in water in both the tanks are equal? Say for example like this, here also this much water, here also this much water. At that time, whether the current of water or water current will be present in this pipe? No. That means when the difference in potential is equal to 0, then the current is also equal to 0. Then that means there is no current at all. So how to define this potential and potential difference? The potential is nothing but the amount of charges which are present at one particular side of a conductor. And what is the difference in the potential? Difference in the potential. Potential means we already know difference in it. That is called as the potential difference. Then who brings about this potential difference in the case of a conducting wire? So we call, there is an apparatus called as a battery. So this is how to represent a battery. One side is larger, one side is smaller. So this is nothing but an apparatus which acts same as that of a pump. What does the pump do in water, in a tank? It will keep the difference in the height of water between these two ends of the pipe. Similarly, the battery, the positive and negative of the battery, there are two sides for a battery. Positive and negative sides of the battery will maintain a sufficient difference in the potential of the charges between the 2 points, though that particular value is called as a potential difference. So how to define the potential difference? So the electric potential difference between 2 points in an electric circuit carrying some current is defined as the work done to move a unit charge from one point to the other point. What is the potential difference? Then definition of potential difference: it is nothing but the work that has to be done to move a unit charge. We have already studied about the charge. That is nothing but movement of charges create electric current, right? movement of charges create electric current. That is why, so in order to move one charge from this particular point to the other particular point in any conductor, then what we should do? We should do some work. Say for example, in order to change the position of any body from here to here, what I have to do? I have to do some work. So that work itself, that work done to move how much? To move a unit positive charge. Unit positive charge means unit charge. Here it is given unit charge, or in general, in specific, we call it as it is a unit positive charge from one point to the other point. Say for example, if we want to do a work equal to W to move a charge from here to here, we are moving a charge was initially here, we have moved that charge from here to here, we have done a work W to move a charge of 1 coulomb. Let us assume unit charge means 1 coulomb. Then the potential difference between these 2 points, potential difference between these 2 points is said to be potential difference is equal to potential difference, PD, is equal to work done divided by work done per unit charge. That is, charge is represented by the letter Q. So work done per unit charge. That is, the electric potential difference V is equal to work done W divided by the charge Q. Work done W divided by the charge Q. That is it. That is the definition of potential difference. What is the definition? It is the work done to move a unit charge from one point to the other point. That is, the formula for that is electric potential difference. Remember, the potential difference is represented by the letter capital V, and work done is represented by the letter capital W, and the charge is represented by the letter capital Q. So electrical potential difference V is equal to work done divided by charge, or W by Q. So next we shall discuss about SI unit of electrical potential difference. Now, knowing about what is the difference in potential or potential difference, we have to know which is the unit used to represent that potential difference. Which is the unit we use normally, that is called as volt. So volt is the SI unit of measuring the difference in the potential. How that volt comes into this particular scenario is, say for example, we know that what is the definition of electrical potential difference? The definition of electrical potential difference is V equal to work done divided by Q. Work done divided by Q. W by Q. Q means the charge, W is the work done. Or what is the unit of work done? Tell me, what is the unit of work done? It is joule. Joule is the unit of work done, and Q means coulomb is the unit of charge. So then, therefore, I can also write it as joules per coulomb. That is, potential difference V is equal to joules per coulomb, I can write. So similarly, or joules per coulomb itself, that itself is called as 1 volt. Remember, don't get confused. Joules per coulomb itself, that itself is called as 1 volt. So that is potential differences. Next, how to measure this potential difference? Let us assume there is point A and point B. How to measure the difference in the potential between the points A and B? We need to know the difference in the potential between A and B. How to calculate that? How to find out that? You have an instrument. That instrument is called as a voltmeter. So that device which measures the difference in the potential or the potential difference is called as a voltmeter. Then how it is connected in a circuit? In order to measure the difference in the potential between these 2 points, how it should be connected? It should say, for example, there is a circuit, there is some electrical instrument here. Let us say there is a bulb or any instrument. Say there is an instrument here. So we need to find out the difference in the potential between these 2 points. How to measure the difference in the potential? Difference in the potential can be measured only by looking at what is the potential here and what is the potential here. That means we need to compare between the 2 points. That is why always voltmeter is connected in parallel to any instrument. And how to represent that voltmeter? Inside a circle you have to write V, and one side positive, other side is negative. This is the symbol. This one is the symbol to represent the voltmeter. So voltmeter is connected like this. So this is the symbol of a voltmeter, and voltmeter is always connected in parallel to any circuit. That is how to connect the voltmeter. Next, we have studied about the SI unit of potential difference as volt. Now how to define it? So they may ask you in the exam, define 1 volt. So that is the question, define 1 volt. How to define 1 volt? What is 1 volt equal to? So we already know that. What we know? That is potential difference is equal to work done per work done divided by what? Work done divided by the charge. So that can be written as W by Q. So when it will, that is potential difference is represented by the letter V, which is equal to work done, that is W divided by Q. By looking at this particular formula, can you say that when this potential difference, we know that the potential difference is represented by the SI unit volt. So when will this V equal to 1 volt? When it is possible? It is possible only when W is 1 joule and Q, that is a charge, is 1 coulomb. That means when the potential difference will become 1 volt only when the work done will be 1 joule and the charge will be 1 coulomb. Then how to define 1 volt? 1 volt is nothing but it is a potential difference. Let us assume that these are the 2 points A and B. So between these 2 points the potential difference is said to be 1 volt. Yavaga? When? So the definition of 1 volt is the potential difference between any 2 points. The potential difference between any 2 points is said to be 1 volt when 1 joule of work is done to move a charge of 1 coulomb between these 2 points. That is, say for example, the potential difference between these points A and B, it is said to be 1 volt. When? That means if we do 1 joule of work in moving how much charge? 1 coulomb of charge. From where to where? Between these 2 points. Then if we do 1 joule of work in moving a charge of 1 coulomb between these 2 points, then the potential difference between the 2 points is said to be 1 volt. That is the definition of 1 volt. That is a very important question. That is, define 1 volt. It is a work done. If 1 joule of work is done to move a charge of 1 coulomb between any 2 points, then the potential difference between the 2 points is said to be 1 volt. Next, we have to discuss about the circuit diagrams and the circuit symbols. So what are the circuit symbols which we use in the case of any drawing any circuit diagram? So there are some basic circuit elements which we have to know. So let us discuss these one by one. How does an electric cell is represented? A cell is represented by like this. So one side is short, one side is short one like this, other side is longer line and with the two lines. This is how there towards the shorter side it is negative, towards the longer side it is positive. That is how to represent a battery, sorry, a cell. And then what is the difference between a battery and a cell? Actually, cell is a single cell and battery is combination of cells. ಈ ತರದ combination cells we need to join. Say for example, this is negative, so that completes one cell. That should be straight lines. Remember, these are the straight lines. This is negative, positive. Then that is connected to some different cell, that is like this I have connected. So next end again it should be negative end. So how to represent a battery? It is a combination of cells like this. One cell, here to here it is one cell, it is negative, here it is positive. So negative, positive, that we write like this. So it is the combination of many cells, negative and positive. And a plug key or a switch, both are one and the same, but it is open. Open means plug key. How to represent a plug key which is open? Like this, open plug key. And next is plug key or switch which is closed. So how to what is the difference between a closed key and a open key? That is, closed means here there should be a dot. So here there should be a dot in the center. So then it is a closed switch, or that means current is flowing through this. And a wire joint. A wire joint. How to represent a wire which is joining? So this is a wire. There is a joint here. You can't simply write like this. You have to specify with a knot there, with a dot there. So there should be a dot here, bigger dot here, so that the dot represents there is a connection. There is a joint between these two wires. Then if two wires cross each other without joint, let us assume that this is a wire and there is one more wire which crosses each other without joining. So this is how to represent these two wires which are crossing each other but without joining each other. And electric bulb. How to represent an electric bulb? It is how to represent an electric bulb. This is how to represent an electric bulb. Sometimes this circle is made, sometimes this circle is not made. So this is also the symbol of a bulb. And a resistor. Resistor is represented like this, remember. So the zigzag lines like this. This is a resistor. And a variable resistor. There are two symbols here. One is variable resistor. How to represent a variable resistor? Variable resistor is represented like this. So like this, zigzag with an arrow mark over it. So that is a variable resistor. Which one? This one is a variable resistor. Variable resistor. And how to represent a rheostat? Rheostat is represented like this. So it is also a resistor like this, zigzag line. So but rheostat is represented with an arrow mark over it. That is how to represent a rheostat. And ammeter, this I have already discussed. That is, ammeter is represented like this, A inside, writing a capital A inside it. So it is capital A inside. So that is ammeter. Towards one side it is positive, towards other side it is negative. And voltmeter is represented like this. So towards one side it is negative, towards other side is positive. Any side you can represent negative and positive. These are all the circuit symbols. These are very important for as far as the examination point of view is concerned. So next we shall discuss about the summary. The summary of the things which we have discussed today is, first we have discussed meaning of potential and potential difference, and next we have discussed definition of potential difference and the SI unit of potential difference and the definition of 1 volt. Very important question for the exam, that is definition of 1 volt. Circuit diagram and circuit symbols. Out of these many circuit symbols we have discussed, any one or two or three or one or two symbols will be asked for the exam for sure. 100% question it is circuit diagrams and circuit symbols. Thank you.